mechanical engineering design. Mechanical engineering design involves all the disciplines of mechanical engineering. For example, for this journal barium, and so I got this picture from this website to give them the credit. The journal barium, and we will this is journal barium. So this is the barium. This is called journal, and this is a barium system. So this barium system includes a fluid flow of the lubrication and heat transfer. If you rotate too many times, we generate this heat because of friction. And the friction energy transport from one place to the neighboring area. Material selection and what kind of material you should select for this journal and for this is a barium, and to maximize the service life. The thermomechanical treatments. For this material, in order to maximize the service life, and you are supposed to do some thermomechanical treatments. And how can we do that? So if you are taking the material science class, and I think the instructor will teach you how to do the heat treatment and to make some components harder and also stronger. The statistical descriptions, and this is statistical descriptions, because for each of these, this is the journal, this is the journal barium. So even though nominally they are the same, but actually a lot of aspects they are not the same. So that means we will have statistical description for this bunch of this is barium, journal barium. Questions? No question. So the design process. So the design process is iterative in nature. So usually when we want to design something, because we do not have any idea about this component or system, first at the very beginning we always pat our head and to move on. Okay, have to start from there. But sometimes we need to modify our this is the selection of the material, selection of manufacturing processes. We need to modify a lot of things. How to modify? We need to based on the performance. So that's the reason we say iterative in nature. So requires initial estimation, just this, pat our head to move on, and followed by continued the refinement. So identification. So this is the flow chart. Identification of need. So then is a need. So the customer give you this problem statement. Say, well, I want to have these kind of components or systems. So I want please design this one for us. Identification of needs, and then you define the problem. Okay, define the problem, and then you synthesize, and then analysis and optimization, and finally evaluation. So after that, you give the presentation to your customers. So for each of these steps, okay, so from this step, identification of need and definition of problem, and you might need to some iterations for the refinement. And from here also, definition of problem, synthesis, and you need to several iterations as well. This is from synthesis to analysis and optimization, several iterations, evaluation. See, you can evaluation can go back here, can go back to the synthesis, can even go back to the very beginning, and also sometimes goes to the definition of problem. So as I said, whenever we want to design a new component or new system, and we do not have any knowledge of this system, at that time, and we do some brainstorming. We have some brainstorming sessions within our team and come up with some ideas. Then we start from there. As I said, once you go through this process, and you need to evaluate what you have got. If this one does not make sense, you need to come back and to do the requirement. All right? Questions? So if you are very lucky, one shot you get a final result. But the probability is very low. Okay, guys, I need to tell you, I need to discourage you. That's the reality. And then we talk about design considerations. When you design something, you need to consider the following things, including but not limited to these aspects. So definitely functionality. So this functionality you need to consider whether after I get this component, can this guy serve the purpose? The strength and the stress, and you need to do the stress and stress analysis. And you need to do distortion, deflection of the stiffness. So these are two different aspects where corrosion, safety, reliability, manufacturability. So if you have all these ideas, very good ideas, but you find out that the components you want is not impossible to be manufactured, but still a problem, right? Utility, cost, refriction, weight, and life. I will not read all these things. And finally, there is the remanufacturing and this resource requirement, so liability. So you need to consider all these things when you design some systems. So luckily, so we have computational tools as this is computer technology evolves. We have very powerful computational tools. Computer-aided engineering, we call CAE, and any use of the computer and software to aid in engineering process. So includes computer-aided design, we call CAD, the drafting, and 3D solid modeling. So I believe we have the SolidWorks in our Oxford now. And then we have computer-aided manufacturing. I will get this model, and you can just send this model and to the CAM. The CAM will generate the G code. And for example, CNC tooth parts, rapid prototyping, etc. So engineering analysis and simulation. So you have finite element, fluid flow, the CFD, dynamic analysis, motion, etc. The math solvers, for example, spreadsheet for the Excel is very good for calculating things. Procedural programming language and equation solvers, etc. So with all these tools and our design, this task can be very fun. I mean, very facilitated. So it will be much easier. What questions regarding the? No question. And we move on to the next slide. Economics. Economics is very important issue also. Sometimes when we design something, we must consider our budget. So cost is almost always an important factor in any engineering design. And use of standard sizes is the first principle of cost reduction. So it is highly recommended that we use standardized components. We do not use customized components. But why? Because standardized components can be produced in mass fashion. So that means the cost will be much lower than the customized component. So the table look at this table A17 lists some typical preferred sizes, and certain common components may be less expensive in stock sizes. So safety and product liability. And the strict liability concept generally prevails in the US. A manufacturer is liable for damage or harm that results because of the defect. If some customer buys your component and finally, so this guy is hurt while operating your component, and you will be sued. Okay, I'm not kidding. That's true. So that's the reason when we design something, we may need to make sure we are safe. Then how to make our safe? That means our product is safe to operate. So negligence need not be approved. And calls for good engineering analysis and design, quality control, and comprehensive testing. So the customer, we need to focus on this customer focused is a design. The strengths and the stress and strengths. So these two concepts are very close, but they are different. Can somebody tell me what is the stress? What's the difference between these two guys? No volunteers? The strength is a material property. The strength of the material property. The stress is actually the stress level when you apply some load, certain load. with boundary conditions. One is material property, which is you cannot change. If you want to change the strength, you need to change to another material. And the stress, it depends on your loading conditions and boundary conditions. So the strengths are inherent property of material or of mechanical element depends on the treatment and processing material and how you the heat treat it and how you process it may or may not be uniform throughout the part. So example, ultimate strength and yield strength. We call you the strength. The stress, as I said, the stress is associated with certain loading conditions. A state property at a specific point within a body, primarily a function of loading and geometry, and sometimes also a function of temperature and processing. So you need to know this the difference between these two concepts. So uncertainties. So these uncertainties, the common sources of uncertainty in stress, and all this is a stress, right? So the composition of material and effect of variation on properties. So we say, suppose we have this alloy, metal alloy, and nominally, this is combinations of different elements are such, but actually, when the people build these stocks, they are not, this is not the case. Right? This is called one source of uncertainty. So second one, variation in properties from place to place within a bar of stock. For example, this is suppose this is a workpiece. Sometimes here the mechanical property is different from mechanical property from here. So the effect of processing locally or nearby of properties, I will not read all these things, and you need to have this concept of uncertainty. Uncertainty means that we have no control, right? We have no control because we are using some this workpiece. This workpiece is built from other people. So the stochastic method. So based on the statistical nature of the design parameters, stochastic, and focus on the probability of survival of the designer's function, often limited by availability of statistical data. So uncertainty stochastic method. So they are related. So uncertainty, the first one is a deterministic method, and we have this is one concept called design factor ND. Design factor ND is defined as a loss of function parameter if, over this maximum allowable parameter. For example, so this is actually this design factor is a safety factor we talk about. Okay, a safety factor. So this is a general definition. And so for our case, we usually use this ND as a design factor or the safety factor. And it is designed as loss of function stress S divided by allowable stress. So this ND usually is greater than 1. Right? ND greater than 1, that means safety factor is supposed to be greater than 1. If you use this is very, very small one, less than 1, that's not good for you guys. You want to kill somebody. I'm kidding. Okay, so the safety factor needs to be higher than 1. That means we consider this uncertainty, all the uncertainties. So we want to make sure the operators who are going to use our components and they are safe. The stress terms must be of the same type and units. If you want to have used this ND, you must use the same type of these units, and they must apply to the same critical location in the part. Okay, we are talking about the same thing. The factor of safety is realize the design factor of the final design, including running up to a standardized set of available components. Now, this one tells you factor of safety or safety factor and the design factor. So for me, I do usually use them. I see them; they are the same. It's okay, guys. So reliability. Reliability is a statistical measure of the probability that a mechanical element will not fail in use. Probability of failure. Probability of failure PF. Failure F means failure, P means probability. The number of instances of failure per total number of possible distance, and R equals 1 minus PM. This is understandable. So reliability, a series system, a system that is deemed to have failed if any component within the system fails. So this is how we calculate the overall reliability of the system. And this guy is multiplication of the reliability of each of these components. So then we talk about dimensions and the tolerance. The dimensions under this nominal size, we say, so this diameter of this marker is 0.5 inch. So this is a nominal size. The limit sometimes when the manufacturer builds this one, and even though they say nominally, so this guy's diameter is 0.5 inch, but the actual product we get will be different. And so they have maximum and minimum dimensions. So these, the limits, maximum, upper limit, and lower limit. The tolerance is the difference between these two limits. Right? So this is bilateral tolerance. Bilateral tolerance means that the variation in both directions from the basic dimensions. That means that this is my nominal dimension. So this is my lower limit. So this is my upper limit. So actually this is a plus or minus. This is a 0.002. So this one is a bilateral tolerance. Unilateral tolerance means that in one direction I have 0, but in another direction I have some number. For example, this one. I'm sorry, I copied this image twice. Actually, this is unilateral. This is a tolerance. Then we talk about clearance. The clearance means the refer to the difference in sizes of two meeting the cylindrical parts such as bolt and this hole. Assuming the internal number is smaller than the external number. Remember, the dimensional clearance difference in the two diameters, the radial clearance difference in the two radii. So interference, the opposite of clearance when the internal member is larger than the external member. So we call this interference. Allowance, the minimum stated clearance or the maximum stated interference of these meeting parts. This is called allowance. Tolerance here. So this is a tolerance. The tolerance, choose tolerance generally increases the cost if you choose this one. They require additional processing steps and require additional inspection, require machines with lower production rates. So this is very, very important. So here's an example, guys. Suppose I want to design, this is a power transmission case. So this is the design requirements given by the customer. So this is a power to be delivered, input speed, output speed, and service life. So all these things. So this is a design